So hi to all, welcome back to the video session again. So in the last video, I have covered Unit 3, Cybercrime Issues and Challenges. The topics are Introduction to Encryption and Cryptography, Cryptographic Functions, Cryptographic Types, Cryptographic Trust Models, Cryptographic Key Pair. These are the topics I've covered in the previous video. And today's video, I'm going to cover on the highlighted red color part, the 6, 7, 8, and 13 and 14 topics. So prior, if you know what is cryptography, what is encryption, what are the different types of cryptographic functions, and what are the cryptographic types are there, that is public key cryptography, symmetric and asymmetric cryptography. If these are known, then we can use that further for encryption in our daily usage. We'll see one by one. So the first one is about the disk encryption using Windows BitLocker. So I want to encrypt my own source of data, right? So until now I taught you what is encryption, right? That is conversion of plain text into ciphertext. Various methods are there. So suppose I want to, or you want to, right, encrypt your Windows data. What we have to do? For that, we have to use an option called BitLocker. BitLocker driver encryption is a data protection feature, right, offered by the latest versions. Example 11, it is available. Windows 11 Pro Enterprise and Education, it is fully supported, whereas Windows 11 Home Edition, it is partly supported. So it allows us to encrypt our entire disk drive, including the Windows partition, and removable USB drives very securely. So this will protect our sensitive data if our computer gets stolen or lost. So suppose it get lost, if we fully encrypt our disk drive and keep it safely so that nobody can take out the data from our system if in case the system is lost, the computer or this laptop is lost. So it offers a secure way to even to dispose our old computer. So if you fully encrypt and dispose it rather than deleting all the files, you can do it, because even the deletion of files, I've already told you that it will be available in the hard disk only until it is overwritten. So it will not fully get deleted. So if anyone wants to try to take our data, it is possible, right? In that case, BitLocker is one of the method to encrypt and throw away the old computers. So in addition, BitLocker also helps to secure the computer against sophisticated software that targets the computer firmware level. So what does BitLocker use is, it uses the AES, Advanced Encryption Standard Algorithm, with a 128 key size. For example, it can also use 256. The drawback is, if we use 256 key size, it will be advantage because it will be highly secure. But the problem is the computation complexity. That means we require a high configured system to do the BitLocker encryption. So for individuals, more than 128 key is sufficient, whereas for companies where they deal with sensitive data, 256-bit key size is required, which gives a maximum protection. So how to do the encryption using Windows BitLocker? So the default key size is 256, right? So how to change that default key sizes. The press Windows key and R, that means run key. Enter gpedit.msc in the dialog box, and then press enter to access the local group policy editor. Go to the computer configuration, administrative templates, Windows components, BitLocker drive encryption. So in the right pane, you can double click, choose the drive encryption method and cipher strength. In that case, you are using Windows 10, or if you are using Windows 7 or 8, select the corresponding setting. Like this. If you choose here, see at the left side pane, BitLocker drive encryption, then choose the drive encryption method and cipher strength Windows 10. Like this, you have to choose and then move upon. So to change the default BitLocker key size to 256-bit AES, in the new window, select enabled, click the drop down box. There it will be asking whether system drive, fixed data drive or removed data drive, and select the AES CPC 256-bit. So that's the method. So BitLocker will use the 256-bit AES CPC encryption for any new drive you want to encrypt. But existing drives, whatever you encrypted using the older version, that is 128-bit, it will stay the same. So this is what you have to choose. See enabled up here, and then choose here AES CBC 56-bit and click OK. Now the disk encryption using Windows BitLocker. What and all you can encrypt? As I said, you can encrypt the entire the operating system in the system, right? The entire hard disk, or you can also encrypt your removable disks. All things are possible. So we're going to see that one by one, and also the best practices using the BitLocker. The first is Windows and fixed data drive, how to encrypt. So encrypting Windows drive. Your OS partition should be formatted to do this. If you want to encrypt the Windows drive, we have to do the OS partition formatted using the NTFS, which is your new technology file system, because it organizes how data is stored on a disk, keeps tracks of files, folders, permissions, etc. Right? So a system partition that should be at least 350 MB. This partition is necessary to store the Windows boot files because Windows cannot recognize an encrypted bootloader at startup. And this partition should be formatted as NTFS for computers that use BIOS firmware, whereas FAT32 if they use the UEFI, where UEFI means Unified Extensible Firmware Interface. It initializes hardware when you power on the system and loads the operating system. This is the purpose of NTFS as well as UEFI. So we have to choose the NTFS for BIOS firmware, whereas FAT32 for computers, if they use it, we have to use the UEFI firmware. So next is encrypting the fixed data drive. So previously we have seen about Windows drive, right? So Windows drive is separate from fixed data. I hope you all know where the Windows operating system is located. For nowadays we keep it in SSD, right? We have a separate, in that only we store the Windows operating system, whereas D drive, say E drive and all is your fixed data drive. So how to encrypt that one? So Windows will not prompt you for the decryption key upon boot up in case if it's a data drive. Whereas in case of its operating system drive, it will ask us the decryption key. So instead, we can double click the encrypted disk drive after booting to Windows and then re-enter the password in the prompt to unlock the drive. This is the way you have to unlock it. So if you lost the unlock method, right, we have to access the BitLocker drive. You must press the escape button upon booting to Windows. Then when BitLocker prompts us to enter the password, we have to insert the USB, then we need to provide the recovery key. This is the method. Whereas the previous steps I shown it, like the way only we have to use and start encrypting our data drive and fixed data drive. The last is encrypting the removable disk drive. There are 7 steps is there. So first is we are very well know that we are doing for removable disk, that means USB. So first we have to insert the USB, right, which we want to encrypt. Then right click the USB drive. Once we open that Windows E key, right, Explorer will open. Then in that right click the USB drive and turn on the BitLocker. And then BitLocker wizard launches and asks us to choose how we have to unlock this drive. We have 2 choices. One is a password based, another is a smart card based. In case if we use the first option, a password is required. Whereas a password, after entering the password, we can unlock the drive. So click the next button to move to the next screen. Then BitLocker will ask us how to find a backup for a recovery key in the event that we forgot our password. Select the preferred method and click next. So BitLocker will ask us how much data on your drive you want to encrypt. That is also in the USB drive, how much data we have to encrypt. We can encrypt use the space only or encrypt everything. Select the choice as we want and click next. The next result screen asks which encryption mode to use, because we are encrypting a USB stick. Leave the encryption mode to set to compatible mode and then click next. The final wizard asks if you are ready to encrypt the drive. If you are ready, then click start encrypting the button. This is the method. What are the best practices when using the BitLocker? We use a strong and complex password we have to use to protect the BitLocker drive, because we are using a BitLocker for encryption, right? Simply using a easy password will make the attackers very easy to attack or decrypt it or do a brute force and get out the password, right? So that should not happen. We have to use a strong and complex password and keep our BitLocker recovery file in a safe location. It is better to store 2 copies of each key in a separate physical locations. We can also store it in a USB, and that is, if that USB is lost, then again the password is exposed. That also we should take it. And then make sure the name of each recovery file reflects the computer or tablet name or remote drive, so that we are not confused about it. We have to use a multi-factor authentication for operating system drives for enhanced security. So, for example, we have to store the startup key on a USB flash drive, right? The third party, right, that we have to store in a USB flash drive. and select the USB authentication. We should not confuse it with the recovery key. So the previous case I said we have to store with the recovery key that reflects the computer tablet name or removable, right? Remember that. So we should not confuse it with the recovery key. So a USB authentication key, also the startup key, is a file with a .BEK. So USB, if it's specific to USB, it will be the key will be stored with the extension .BEK. So from this we can able to identify. So before upgrading our operating system, we make sure that to suspend the BitLocker protection. Otherwise, we have to again, the option, it will be really confused for the operating system, or we have to do the BitLocker again, or it will ask, maybe the updation process will not happen very, upgradation will not happen very perfectly, all these issues will come. So it's better to suspend the BitLocker protection. And we make sure that we suspend and resume the BitLocker protection after we perform a recovery of the local locked drive. That also is the next practice. And we make sure that to turn off the Windows PC or put in hibernation mode when we finish our working. And if we suspect that the BitLocker keys have been stolen, make sure to decrypt the drive and then encrypt it again to avoid leaving any traces so that a hacker can get it out. And for people storing the sensitive data on their machine, it is advisable to encrypt the drive first before moving the sensitive files to it. Drive itself should be encrypted. Then you start moving the files. So what are the open source tools available now? I said that we have to use a BitLocker, right? That's a proprietary because Windows 11 Pro and Additional is available. Windows for the home, it is not freely, that much not 50% of usage only. It will be applicable for us in the free version. So what we have to do is we have to use some open source tools. The very good tool is VeraCrypt. So if you could see the difference between open source and proprietary, I have listed out here. Open source is more trustworthy, whereas proprietary is less trustworthy. Why I do say such things? Because open source, because it is the source, the background of the software, that means the coding, everything's available openly, right? Then people would have very keenly or very securely they would have made this open source software, whereas proprietary softwares are less trustworthy because anytime you want to hack it, we can hack it very easily. So many backdoors will be available in the proprietary, whereas no backdoors in the open source. And reputation of being more stable and interoperable with other open source products and protocols will be well observed in your open source software, whereas in proprietary is linked to only one vendor, which can impose restrictions on its usage and other system that can integrate with it. So popular programs is used by millions of users and has hundreds of volunteer developers, making open source software more stable, much secure and less prone to bugs. Whereas proprietary means paid versions, right? So many users will not be there, only less users will be there. It is unstable sometimes and less secure and more prone to bugs. But only major drawback with open source is not very easy to use. Whereas proprietary, the person from the company who is actually selling off the software will come in person and give a session. In fact, they'll give a session to the people who are going to use. They'll select some few members from the organization. They will also teach them how to use. They'll practice them. All these things will not happen in the open source. It is only the person who is installing it have to read the instructions and follow up on. And better than in regard to cryptographic tools, it is not better. Proprietary software is not better. So how to select the open source software? So make sure that select an encryption tool that incorporates open source and cryptographic algorithms like two-phase and world. This is the first requirement. Second is check what current users of the software say about it. We have to do online search online for any problems, major bugs and security flaws related to it. Check whether any expert in the field is available who may have given an audit or review of the software or what is their opinion. See, whenever we buy a product, we generally do this. Right? Even in Amazon, if you want to buy a product, we just see the reviews, comments, whatever is given, and then only buy the product. Same methodology is followed here. So we have to use a mature software. A program with millions of downloads is better than a new one just developed, right? And it should be updated continuously and kept active. Such softwares only we have to choose. The most popular, open source encryption program in the earlier days was TrueCrypt. For years, it has been the number one choice. One man show like that. It was by security people, professionals were using around the world. And TrueCrypt can be installed on different platforms because it supports Windows, Linux, right? So all this was supportable. And but The problem is TrueCrypt development ended in the year 2014 through a message in the website stating the following: that using TrueCrypt is not secure as it may contain unfixed security issues. So very slowly, TrueCrypt developers started moving to VeraCrypt, and then they've started using it because some unconvinced flaws were available in the TrueCrypt software. And the final summary found that TrueCrypt has no evidence of backdoors or otherwise intentionally malicious code. However, the code suffers from some vulnerabilities resulting from using some deprecated functions and inconsistent variable type. Because of that, TrueCrypt was dropped out. So the popularity of TrueCrypt only, keeping that in mind or keeping as a background only, VeraCrypt and CipherSheet was developed. Now VeraCrypt is very commonly used nowadays. So this is based on the TrueCrypt only 7.1a version. It adds enhanced security to the algorithms used in encryption and fixes major security bugs found in the TrueCrypt security audit. And CipherSheet, if you could see, I have given the net URL also where to use it out. This is another fork based on TrueCrypt. So it maintains backward compatibility with the previous TrueCrypt container format CipherSet. So for the two things I have given the link, we can use it out from this one. Apart from this, right, these open source tools, what I discussed now is your TrueCrypt, which is dropped out in the year 2014, whereas VeraCrypt and CipherSet are used now. But the drawback is that these tools need an advanced configuration or cryptographic keys, right? Whereas the listed tools, multitask encryption tools, what I'm showing now, which is 7-zip, AES script, protects Microsoft Office files, protect PDF files, right? These do not need any advanced configurations or cryptographic keys in order to encrypt the files and folders. Very easily we can use it up. We'll see one by one what are they. The first one is the 7-zip. So the 7-zip from the URL we can download here is open source archiver software that works on all Windows versions beginning from your NT. So it allows us to compress and encrypt the data using the AES 256 encryption algorithm. And from the term you can see it provides us a zip file. That's what is the real usage of it. The second is the AES script. It can be available from the URL as shown here, www.aescript.com. It's a free open source program that integrates the Windows with the Windows right-click context menu. Right? It also uses the AES 256 encryption. We have to right-click the file to encrypt the file. We have to right-click the file and select AES encrypt. If at all the software is installed, right, we can do it easily. Then enter the password to lock the file. Another file with the same name with the AES extension will appear in the same directory. To decrypt it, we have to right-click the encrypted file and select the AES decrypt, then enter the password. Very easy. It is very handy. We can use it out. The third one is, right, we also have the encryptions, right? Many of us may not be using it actually. Microsoft Office for your Word, PPT, Excel, everything they have provided the protection, right? If you see, the version of Microsoft Office 2013 and 16, you can open the document you want to protect, select the file menu. Even it's available in 2011. I have checked it out. Right, you can open the document you want to you want to protect, select the file menu, go to the information tab, click the protect document button, then select encrypt with a password, enter the password and click it. This is a very simple way of encrypting a Microsoft file. It can be a Word, it can be Excel, or it can be PPT. So in Excel, if you go to the info tab, select protect workbook and select it. In the PowerPoint, you see select protect presentation, select encrypt with the password. These are the methods. So overall, the Microsoft we use for your Word, Excel and PowerPoint. Similarly, we have other very usable document as your PDFs, right? So for that also, Adobe has a password protection feature. So to protect a PDF file with a password, you have to open the file. If you want to protect it, select the file, properties, and go to the security tab. From the security method drop-down menu, select the password security. Another window will pop up where you should select the option requiring a password to open the document. Type the password in the corresponding field, then click the OK button. So, and another pop-up window will appear asking you to confirm your password. This way you can protect your PDF file. So we have seen protecting the Microsoft Office files as well as Microsoft PDF files. And we have seen how to use AES script and 7-zip. So this for zip files, if you see, right? And AES is for your encrypting one file. If you want to use your AES script, you can encrypt a file. These are the methods available. Okay. The next is, until now we have seen what is the method to encrypt, right? Now we will see the opposite phase, right? What are the attacking cryptographic systems available? Right? If you see, we have encryption, we've done the encryption, we know what is the encryption methods, we know what is cryptographic functions, which is again and repeat the CIA triad, which is confidentiality, integrity, availability, authentication, and your non-repudiation. These are the methods, right? Whereas how does a hacker works, right? If they want to attack us, how do they attack? What ways they attack us? That's what is the topic covered here, attacking cryptographic systems. If you could see here, there are 12 topics and we are going to discuss one by one, and these types of attacks aim to find a secret key used to decrypt the confidential data in order to gain unauthorized access. So I say that we have encrypted using BitLocker, but still hacker has a chance or a choice or a method to decrypt it with a key. How it is possible? Let us see one by one. The first is harvested, then decrypted. So we know that the public key infrastructure cryptography method, right? Public key PKI uses the RSA and elliptic cryptography methods, right, for encryption. It is used by the transport layer security protocol, which provides security for online applications such as web browsing, internet messaging for your Facebook, WhatsApp, and all that. So that's your internet messaging for your email, and voice over IP. Voice over IP, many of us were not using nowadays, but before the invention of WhatsApp and all, we use your voice over IP only, right? Voice over IP protocol only was used majority, but nowadays it is slowly deteriorating. Okay. So TLS used these methods. So this can be broken, right? This can be broken through the invention of quantum computers. In China, very well, they have developed the quantum computers with very good configuration, and then started saying that we can able to break the RSA, right? RSA is the highest, very widely used cryptographic methodology, right? That method also can be broken by the invention of quantum computers. So in your harvest then decrypt attack, what they do is an attacker could record the encrypted traffic and then wait until the technology advances. See how they're doing. They're waiting, they're harvesting, right? Harvesting, the term harvest means we have to wait for a certain period. So they are waiting until the quantum computer arrives, then only they'll decrypt the traffic. Like that also people are waiting for the advanced technology. So they will have the encrypted data with them. Once for a while, they will use it out. The next is the DRO double drone, which is your decrypting RSA with obsolete and weakened encryption. This is a drone attack. So, if at all, if our computer still supports the SSL, Secure Socket Layer version 2, I have also told in the previous video that we all have moved to the TLS. Instead of SSL, we have moved to the Transport Layer Security version 1.3. That's the latest version. If any of the system is using SSL version 2, then it is hackable. Right? We decrypting, if RSA is the cryptographic algorithm used, then it is hackable. So we are not supposed to use this SSL version 2. If any of the applications developed using this, it is still hackable. Next is the brute force attack. We have seen much information about this. So what is the new thing is, if at all the encrypted data and the algorithm is known, right? We have the encrypted data and we know which algorithm is used. So what are algorithm possible? AES, DES, RSA, ECC, digital, the Diffie-Hellman, all this digital certificate, all these methods are known. Password guessing is using the tool called John the Ripper, and Rainbow Crack is easier. So that's what they do in the brute force attack. If it is not known, then it is difficult. One of the variant of the brute force attack is dictionary attack. It's very simple, because in the dictionary, how we have words, all combination of words will be there. We have to pick up and put in the password and randomly run the encryption tool and just start decrypting. That's what is followed in brute force attack. The next thing is the OS leak, operating system leak. So the decrypted files or the parts of them, the passwords, encryption keys, cached files, and other secret information can reside in different places. So where and all it will reside in Windows is the paging files, which is in your RAM, hibernation files, memory dumps, and system restore points. These are the places. So operating system can leak, right, these decrypted files via these places. Where these places, if they are not encrypted, their leakage can happen. So that is the reason I taught you how to, encrypt the operating system. I mean, we have how much is the requirement for encrypting the operating system as well as the drives in the computer. The next is very, very, very important attack. Most popular attack is the man in the middle attack, MITM. So an attacker, if you could see in the diagram, victim A, victim B are there. If victim A corresponds to victim B and then victim B is corresponding to victim B, both way communication, right? Normal communication happens. Whereas a man in the middle will come into picture. That becomes a spoofed communication, right? So an attacker intercepts the communication but still relays the message between the sender and receiver as if the communication was not touched at all, right? So discovering such attacks is very, very difficult because nothing appears to be unusual at all. So if Nihad wants to communicate privately to Susan, he needs to request her public key first. An attacker intercepts the communication and sends his public key instead to Susan. So what happens? The attacker is able to decrypt anything Nihad sends to Susan. Capturing one side is not enough. The attacker needs to maintain the connection. So he or she encrypts the data after reading it and resends to Susan. That whatever he wants to send, the man in the middle attack, whatever he wants to send, only that data will reach the victim B. That's the Susan. So the attacker now sends his public key impersonating Nihad so that anything Susan sends is decrypted by the attacker. So both the way communication is happening normally from the Nihad and Susan, they are the victims, whereas in between the man and the middle person is started attacking. He or she only decides what information should go to victim A or victim B. This is called as man in the middle attack. This is a very, very, very dangerous attack. We have to take care of this. We have to do a mitigation for this. The next is bootkit and rootkit, which are hardware attacks. So bootkit is a kind of malware that installs on the master boot record. The keyword we have to remember is master boot record of the operating system. From the term boot means what? Once the operating system gets booted up, right? So this attack is starts. That's what is your bootkit or bootkit attack. So your bootkit initially usually stores its code in the unlocked disk space or host protected area using its own file system when this software is installed, right? So booting itself, if this piece of software is installed in our system, while booting itself, the attack starts. It runs before the operating system boots. That's while booting itself, while start of the system itself, computer itself, your attack will start. So they're giving it the ability to bypass the full disk encryption. Even if you have tried with the full disk encryption, that also can be bypassed. Because the MBI is not encrypted. Master boot record is not encrypted. Only the disk is encrypted. So you can also capture the decryption key as well as the password. So a bootkit can get direct access to Windows kernel, giving it widely, it can perform what other dirty things or bypassing all security software. Everything can be done in the system. So bootkit is very, very important. It should not be installed in the system at all. The next is the rootkit. This is also a hardware attack. So the malicious software, is a malicious software, is a piece of software designed to gain low-level access to the target computer. It works stealthily in the background without leaving any traces. It has the ability to disable security solutions already installed in the infected machine, right? So it can also make modifications to the operating system, like installing a software driver, and then further conceal it, installing a keylogger, installing other malwares. Everything is possible with the rootkit. So detecting a bootkit or rootkit can be extremely difficult because normal antivirus programs cannot detect all these types of rootkits and bootkit software, that is especially the hardware softwares, right? The next attack is the evil maid attack. From the term maid means, example, you can assume that a maid in the hotel. So there, after we are actually checking in a hotel, we are going to a room and then checking in, and then after some time we want to move out, right? Still the maid, that means the cleaning person, other persons can come inside the room and then clean and go. Their access is available. Like that is called as evil maid attack. So an attacker gains physical access to an unattended target PC that has full disk encryption enabled using using programs like VeraCrypt, Pretty Good Protocol, or a BitLocker. So the attacker, like a maid in the hotel, boots the target PC using a CD or DVD. So because it is already encrypted, no, so they use the CD or DVD or a USB, and or even through a network, and then installs a bootkit. That's a backdoor, right? And shuts off the PC. So when the legitimate PC owner returns, he or she powers up the PC as usual, enters the decryption key. Then that time, this root bootkit, right, will capture the key. Via that, we can able to unencrypt the or decrypt the disk. That's what is the background of this evil maid attack. Cold boot attack. This other way, right? An attacker gains physical access to the target machine immediately after it has been turned off. Immediately, right? So you might ask me how this is possible when you are turning off the system. How this can be possible is by using the power button. The attacker can reboot a running machine, right, using the power button. This is called as a cold reboot. That means if the machine is just now turned off and then we are doing a reboot, right, still some information is available there. That information can be captured because ram will be erasing its data only if the system is fully powered off, right. It will take some amount of time. Before that itself, if you do a reboot, right, if the power button is switched on, right, cold reboot, that's immediate. That means immediately we are doing a reboot. Then the attacker can capture the image of a RAM where we have the essential information of any key. For example, the encryption key is stored there, right? We can able to capture that one. After capturing the image, they will get analyze the data to recognize important artifacts stored in it. This is what they do. So see the difference between the evil maid attack, where the person comes in and using a USB or a CD or a DVD and then install a bootkit. Here, in this case, before even switching off exactly, right, immediately they are switching it on by using the power button until the RAM data is available. That's what is the beauty of it. The next three are the direct memory access, hardware keyloggers, and hardware backdoor. Right. So hardware keyloggers may be of two terms, software and hardware. Software is what we have seen, that is rootkit and bootkit. Whereas now we are going to see about the hardware keyloggers. And before that, we'll see what is direct memory access. And so attacker gains direct access to the target's machine's RAM. Memory means RAM, right? By exploiting some type of ports, for fireware ports, Thunderbolt ports, or PCI Express. Using this ports, they're able to access the RAM. It's an attack. In terms of hardware keyloggers, this can be installed between the target computer and the keyboard or simply attached to the DVI, VGA, or HDMI port. An attacker will have the ability to capture everything the user types. We have seen keyloggers, right, the same way, but it's hardware based, not the software based. That means we are not installing a software, a hardware is placed, right. You have to install a hardware between the computer and the key, right. After using that, we can take screen capture and then send the information through email. Like this way, if you do it, when compared to the software keyloggers, hardware keyloggers are very, very vulnerable, right? Unless the hardware is is responding, or we are not able to, the victim is not able to identify the hardware, then it is highly vulnerable. The next one is a hardware backdoor. So backdoors allow the cyber criminals to gain remote access to target machines and networks without being discovered. You see, backdoors means without being discovered. It's really a threat to IT operations because especially when they are embedded in security devices such as access control systems and network. If at all any backdoor is there in an access control system stores a ACL list who and all can access with what level. Right, high level, low level, medium level, all this can be compromised. Very, very highly vulnerable. One of the attack is hardware backdoor. So that's all with the types as I've shown you here. There are almost 12 types I have talked through. Now, these are the attack scenarios, right? These are attack methods. Now, let us see how to mitigate it. How we can mitigate this. This is the offensive side, right? Let us see the defensive. How we have to mitigate this one. With respect to the 4 topics I'm going to discuss today. One is how to do a mitigation using the future attacks against encrypted data, mitigate the brute force attack, operating system leak, and strategies against the physical attacks. Let us see. So the harvest then decrypt attack, which works by capturing the current encrypted data and then waiting. So I said that if quantum computers with very good configuration can break the RSA, I told you right initially. So to defend that one, right, we have to introduce not cryptography, quantum cryptography. If we introduce that, then future attacks can be counterfeited. That is what is the methodology. So whenever there is a attack comes, hacker thinks in one perspective, there will be always a blue hat hacker, right? There's a difference between red hat and blue hat. Red hat will be very, offensive, whereas blue hat will be defensive. So for that purpose, if quantum computers comes, then we have to introduce quantum cryptography only to counter it. So any sensitive and high grade information can be exchanged physically. That's one more way. Whether if you don't want to do this, we can exchange the sensitive data physically, but it is of much not with that much use, because offline we have to exchange. That is not the best way to mitigate. Whereas the best way is quantum cryptography. So quantum cryptography means depends upon physics rather than mathematics. Physics is still date very difficult to crack it out, right? So maths means we have some logic and then we crack it easily, whereas quantum cryptography uses physics rather than mathematics to create its crypto system. Then how to mitigate the brute force attack? Such an attack is not practical against the Windows operating system sign-in authentication or BitLocker, because with the BitLocker password recovery key, when the target machine is protected with a strong complex password and the account lockout is activated, then it is difficult. So Windows also devices with the TPM, which is your third trusted platform module, right? Trusted platform module TPM offers more protection against such attacks. Or you can protect a VeraCrypt container. This is what we have discussed in the previous slide. VeraCrypt container can be used via which we can able to have a lengthy passwords and then encrypt our files. These are the three methods for mitigating the brute force attack. Mitigation means how to be defensive. Then the OS leak. Even if we are using full disk encryption to protect our data, we still need to decrypt the data to access it. Every one of us is sure, right? If you have a full disk encryption, we have to decrypt. So Windows stores, as I already told you this one, Windows stores the open files and fragments of them in different locations, like paging files, system restore, in all these places get stored. So, for example, if you want to read a Microsoft Word document stored inside a VeraCrypt container, we need to decrypt the container first. Then, after opening this document, Windows needs to upload it into the computer RAM to make it available for reading. So, in the same way, Windows will record opening such a file in different locations, such as recently opened files, Microsoft Word history files, and some other places, system restore points. So, in all these places, we have to configure it. So what we have to do is, in many places it gets stored, right? To counter such attacks, we have to configure Windows properly to limit the cases. We can do it, but we have to write a rule, or manually we have to do it out. In that way, we can fight the OS leak attack. So how to do it? First one is disable the memory dumps. Second is disable the Windows hibernation. Many of us, I even asked in the class, how many of you would switch off your system regularly? Many of them are not raising hands, right? Very often we don't switch off the system. In those cases, it will be hibernating, right? It will be still on only. So in those places, we have to disable. Third is disable virtual memory. Disable volume shadow copy service. So first is disable memory dumps. A memory dump file can contain unencrypted data, right? If Windows faces a problem, it needs to restart. So OS leak can happen this way. Or Windows hibernation. So open files, encryption keys, all in hibernation, everything will be open only. That time you can able to decrypt it, or you can even take out the data very easily. Third is disable virtual memory. This feature allows Windows to copy part of the RAM's contents into a special file on the hard drive. So from RAM, you're having a copy on the hard drive to compensate for RAM storage when it becomes full. If a RAM becomes full, a copy of the RAM will be available in the hard drive. So we have to disable that one, because that will not be encrypted. RAM data will not be encrypted. And disable volume shadow copy service. This service allows the Windows to take automatic backup copies of all files and folders. So this imposes great risk. So unless we don't encrypt this also, it will be a problem. So it's a good practice to surf the internet using a limited Windows account to avoid installing any rootkit or any bootkits, and we should keep our antivirus solution up to date. and install a dedicated program to fight against the malware. And also do not forget to set the Windows operating system to update itself automatically, because if any what do you mean by update? If any actually backdoors or any malwares are coming into picture, that is what they're trying to avoid it through the updates. That is the reason always your Windows should be updated. The next is mitigation strategies against the physical attacks. So set a password for your BIOS, and this will prevent the attackers from booting using a CD. So I said that the devil made attacker, we can use a CD, DVD or a USB, right? If we set a password for the BIOS, it is difficult. They cannot do so. And then using a computer with a trusted party module when encrypting disk drives using BitLocker. Then always use a two-factor authentication, even if the computer has a TPM module, right? Even if you could see here the trusted platform module is used, even in that case also, we have to use a two-factor authentication. And then use a computer with Unified Extensible Firmware Interface, UEFI, right? I've explained this in the previous slides. And then stop using the discontinued editions. For instance, XP and Vista should never be used because it is full of backdoors are there. So never use it. Windows versions like 8 and 10 support many features for preventing rootkit and rootkit with updations. That also operating system should be updated, right? So a secure boot is enabled, trusted boot feature is available, and early launch anti-malware feature is available, which supports us the physical attacks, against the physical attacks. And then modern computing devices has new versions of RAM DDR3 and DDR4, which store remnants of information for a limited time and after losing the power. So that also to be taken care. And to mitigate the DMA attacks, we can use the Windows Instant Go certified devices. So these modern computers have newer versions. I said even after losing power, some amount of time the RAM will have the value. So once you reboot it again, for example, the cold boot attack, right, you can retrieve back the data, right? So in that case, we can use the Windows Instant Go certified devices, right, that do not have any DMA ports at all. And to mitigate the hardware backdoor threats, we can use we should buy computing devices from a trusted and reputable vendor. Best advice. Thank you. So I have covered almost what is. I'll go to the first one. What is disk encryption using BitLocker? Apart from BitLocker, what is the other tools available? VeraCrypt and TrueCrypt. TrueCrypt is not used. VeraCrypt and CipherSet is used. And then apart from this, other encryption tools like multitasking, because we don't have much configurations. We don't have Windows Pro 11 Pro edition. We can use your Word itself. That means Microsoft Office itself has a inbuilt encryption is available with the password. Then PDF is available, zip file is available, AES script is available. So such tools can be used. And I've also said that this is all the tools can be used for encryption. Suppose what happens if the attacker comes with the various ways of attacking. For example, 12 ways we have seen, right? And how to do the countermeasures against these cryptographic attacks. So these are the methods and techniques and information conveyed through this video. Thank you once again.